Oh, okay. So I was just muted. So, all right, guys. So what we will do is we're gonna continue with our discussion. We'll just complete chapter 13. Can you guys check to see if this is actually working on your end? I'm not sure why mine is showing it like that. I believe it should be working properly.
I think if you wait for it
Doctor,
to load بترجع بتصير عادي.
Oh, okay. If you
yes,
wait.
doctor, if you wait for it to load, it's normal.
Oh, okay. Okay, great. All right. So what I recommend is you guys start by reading these. Read all the history on dynamics. Try to really understand, the basically the background of how these equations came to exist. Obviously, we are deriving all these equations, but try to spend some time, when you can, basically try to read in the textbook. Read more about it because it's a very important course. And like I said, dynamics is the essence of controls, robotics down the road. There's a lot of things that you can learn from this course that will actually help you a lot down the road, especially if you are looking into getting a master's maybe or a PhD or starting your own company, whatever that you want to do. This is a very important course. All right. So what we're gonna do today is we're gonna start. So now we know how to find the accelerations. You guys agree? Now, if I have a car going on this road, all of you should know how to find the acceleration, whether you want to choose polar coordinates, whether you have the x and then the y coordinates of the car, whether you have the velocity of the car and then the radius of curvature of the road. You guys agree?
Yes, doctor.
Okay. It's good that you guys agree. Let me.
Yes, doctor.
Okay. Let me start by asking you guys a couple of questions. If you have an elevator, all right? If you have an elevator and you are sitting in the elevator, okay? So, if you have a person sitting in the elevator, basically, if I tell you that the mass of the person and the elevator, the whole thing has a mass m, okay? And the elevator is going up, okay? The elevator is going up, okay? With some acceleration a, okay? Let's say the elevator and the person, this whole object basically, okay, is accelerating with an acceleration a, and this whole object has a mass m. What do you think the tension is going to be in the cable, assuming the gravity is acting downward? What is T?
مش mg.
T is going to be equal to mg.
No, it's more than mg. مش طالع كون if the elevator is going up.
Yeah, more. Sorry, more.
Why more?
لأنه في الأكسلريشن تبع ال A طلعت لوع.
Then it's lifting the elevator up. If it's the same, it won't be lifting it up.
Okay. طيب. Okay. As the acceleration is 0, okay. What is the tension in the cable?
MJ بتصير.
mg.
mg. Yes, mg.
Okay, we all agree on that, مظبوط. If the elevator is going up, what is the tension in the cable?
mg plus A
minus mg.
mg minus A.
mg minus A لحالة؟
لا يعني m factor the g plus A.
Bravo, exactly. عافيك. This is very good. So mg plus ma. Okay. mg plus ma. If you have no acceleration, مظبوط, basically it's static, right? Even if it's moving at a constant velocity, acceleration is going to be 0. So the tension in the cable is going to be equal to mg, مظبوط. If you begin to accelerate it upward, basically T has to be equal to mg. Now you also have to add to it ma because you're also accelerating the object. You're not only carrying its weight, but now you're also accelerating it up. Okay, what if A was opposite? What do you think is going to be? Let's say the elevator is actually accelerating downward. What is going to be the tension in the cable?
ساعتها mg minus ma.
mg minus ma. Okay. So what I want to teach you guys, instead of you guys not having to guess about it, right? Engineering shouldn't be about guessing or best guessing or whatever. We're going to develop a framework. for you to be able to, you know, any person can use that framework and then to be able to analyze all dynamics problems. And what we're gonna do is we're gonna separate the forces alone, and then we're gonna put the accelerations alone, right? Here we assume this whole thing is one object. So here's what we're gonna do.
So we're using Newton's law.
Exactly, this is Newton's law, yes. So what we will do is we're gonna draw the same figure. So this is my elevator, okay? Newton's law is F is equal to ma, and then this is exactly what we're doing. F is equal to ma, but we're kind of looking at this graphically. F is equal to ma, so I have the external forces here, and then, so on this diagram, I'm gonna put external forces. Here I'm gonna put inertial forces. Inertial forces, it's never acceleration alone. It will be acceleration multiplied by the mass. Later on, we're going to have rotational acceleration. So if you have a rotational acceleration, we multiply it by rotational mass. Rotational mass is equal to I, or inertia, which is equal to, you know, summation of mr squared. We're going to look into it later. Okay, so what are the external forces on the elevator? What are the, let's analyze the same problem. Let's analyze the same problem for the elevator going up. What are the external forces on the elevator?
The tension of the cable.
Okay, so the tension, I'm going to put it as a vector, tension.
Gravity.
Okay, gravity. So gravity always apply at the center of gravity of the object. Now it doesn't make a lot of sense, but later on, the gravity may cause rotations of the object. So we'll have to always remember the mg has to be at the center of gravity. So this guy is my mg, right? Okay, if the elevator is going up, what should I draw on this figure?
An arrow up.
Exactly, but it's going to be equal to what?
A.
MA.
MA, okay, this is never A, this is MA, and then MA here is also at the center of gravity. It's inertial force, okay? So the tension, I can put the tension, I can hook the elevator at any point that I want, but the MG will always be at the center of gravity. So if you use like, you know, CAD model, like SolidWorks, whatever, you can always find the center of gravity of your object. Okay, likewise, wherever that you have mg, you will actually have ma. Here, ma is actually acceleration of the center of gravity. Okay. Later on, we're going to know that every point on the elevator will actually have its own acceleration if it's rotating. But here, the object is not rotating, so it's translating only. So all the points on the elevator will have the same acceleration, including the acceleration of the center of gravity. So here, I implicitly mean that this is acceleration of the center of gravity. Okay, how do you think we can come here to get this equation? So here's what we'll do. We're simply going to sum the forces, okay? We'll sum the forces in whatever direction that you want. Whatever direction, but whatever direction you use, you have to use that direction in the same diagrams, in the two diagrams. So I can choose to sum the forces in the upward direction, okay? So summing the forces in the upward direction is going to be equal to what? Can someone help me out here?
Tension plus
It's going to be T, mazboot. So this is my positive direction. So any force that is pointing upward will be positive. Any force that is pointing downward is going to be negative. مش هيك؟
Yes.
So it will be T
plus MA
لا هون بعدنا هون على الفورسز. So I'm summing the
minus MG.
minus
minus
MG.
mg. So T minus mg, right? بعد في شيء force هون؟ لا, right? So T minus mg is going to be equal to what? So whatever direction I use to sum the forces, I'm going to use that same direction to sum exactly MA. There you go. So now I can actually solve this equation. So T is equal to mg plus MA, or M equal to G plus A. Does that make sense? So this is really how we got to that equation. But here what we're doing is we're, you know, separating the forces and the accelerations. We sum the forces in one direction, and then they would have to be, you know, T minus mg is going to be equal to MA. So here the forces alone. So just like what I did here, summing the forces in a vertical direction, I can also sum the forces in the x direction. What is the net force in the x direction here?
0.
Therefore, I have 0 acceleration. So these forces must be equal to these forces. So this is what Isaac Newton derived really like 500 years ago. Is these forces must be equal to these forces. These forces are the forces that you don't see, right? MA. And these are the forces that you are aware of, okay? And then this is how you can find the acceleration. So acceleration is directly, you obtain acceleration directly from the forces. Once you have the acceleration, you can integrate that, find the velocity, and then find the position. That way you can basically, given these forces, I can actually ultimately find the position of the elevator as a function of time. Okay, and then this is how the elevator is being controlled, right? Ultimately, by applying the right forces, you can actually move the elevator. Okay, very good. So if the elevator is going downward, can someone help me? If the elevator is going downward, how this diagram changes?
The acceleration is the only vector that changes, right?
Okay, so
T
T,
equals to minus MA.
does mg,
Yeah, minus MA.
does mg changes here or no?
No, the tension
No.
is still upward.
The tension is still upward, and then the weight is still upward, right?
And downward.
And then this guy is going to be MA. Okay. Okay, let's do that. So obviously T is a cable, right? T is a cable. So if I sum the forces down, I'm going to end up with what? Summing the forces in what direction? Doesn't matter.
Why?
It doesn't matter, right? You can sum the forces in the upward or in the downward, right? But whatever you do on this figure, you're doing. So this is like an equality, right? If you multiply the two sides by a minus, it will give you the same result. So summing the forces in the upward direction is going to give me what? T minus mg is going to be equal to what?
Minus MA.
Minus MA, exactly. So T is going to be equal to mg minus A. Does it make sense?
Yes, doctor.
Okay. All right. Now let's do something. Let's look into it. So if there's an acceleration أصغر من g, what is the value of t? Is going to be equal to that. But what if the acceleration is actually less than the gravity? Or the magnitude of the acceleration, I'm sorry, is greater than gravity? What happens to t?
It becomes negative.
أو شيء.
بتصير downward.
What? Yeah. So tension بتصير downward. What is the physical interpretation of this? That t become none?
Is it that the cable is loose?
No.
يعني الobject is going downward.
بالعكس ما فيها بكون ما فيها الكيبل cannot push the elevator.
Yeah, the cable cannot push. But what if here your acceleration was greater than gravity? So if your acceleration is greater than gravity, يعني شو؟ يعني basically you are pushing your object. If your acceleration is greater than gravity, it means that somehow you are creating an acceleration that is greater than g. So if I let go of this pen, مظبوط. If I let go of this pen, it's going to accelerate downward with what?
G.
With
mg.
g. Why? Because I have no other forces, so mg is equal to ma in that case. Okay, but if I'm actually forcibly want the acceleration to be greater than g, it means that there has to be another force basically. So t is negative. Basically, t would have to be negative, right? To be able to so to be able to create that acceleration that is greater than g.
Do we have a motor or something?
Exactly. In that case, yes. So this is what I want you guys to understand. Like if your t is negative, it means that ultimately, so whatever. So if you have these guys, you can solve for tension. If you have tension, you can solve for acceleration, right? Because this is an equation with two unknowns, t and then a, right? If you tell me that the cable is applying like 1 Newton, then I can basically solve this and then obtain the acceleration. But if I tell you that the acceleration is greater than g, so I'm actually forcing whatever value for acceleration, basically that my t would have to be negative to be able to, or opposite the direction that I initially assumed, to be able to create that acceleration. Okay, but let's just keep it whatever that we had earlier. So the tension will be g minus a. So إذا كانت the acceleration equal to g, then your tension is going to be
0.
0. شو يعني physically?
هون يعني it's loose and it
Static,
doesn't have any
static.
effect.
Free falling, right? It's free falling, right? So if the acceleration is equal to g, then you're not. Then the tension is nothing, right? It's just the rope is basically falling with the elevator, right? If there is any tension in the elevator, then your acceleration is going to be less than that, less than g, مظبوط. It will resist the acceleration, right? So the tension would be 0. Then you have the acceleration is equal to the gravity. Okay, guys, so I think this is just a good introduction for chapter 13. And really, all what we're going to do in this chapter is we're going to be applying this over and over again. And then we're going to be applying this for the remainder of the course. Linear motion or rotational motion or a combination of translation and rotation, we're going to apply this technique basically, placing the forces and placing the inertial forces, which are MA. And we use these basically. So this one is one equation and two unknowns, T and A basically. If you know the tension, you can find the acceleration. If you know the acceleration, you can find a T. In more professional terms, this is called like kind of forward dynamics, right? Forward dynamics is, you know the tension, you can find the acceleration. Inverse dynamics is, given some acceleration, what should be the force that you have to apply? This is called inverse dynamics. Okay, but you don't need to worry about that. Just worry about, recognizing that you have to apply external forces on one end, inertial forces on the other end, and then using these to be able to, find the tension or find the acceleration based on that, and then set up this equation, which we mentioned earlier. T has to be equal to mg plus ma. So when your elevator is going up, the tension has to be much greater than if the elevator is static, right? Okay. Once your elevator is going at a constant velocity, then the tension in the elevator is going to be equal to what?
0.
لا, if your elevator is going up with a constant velocity.
MA انه MA plus G لانه A constant صار.
لا when the velocity is constant شو بيصير
Zero.
constant A zero.
شو بيصير بالتنشن؟
MG بس.
MG بتصير يعني.
بتصير MG exactly. MG ليه؟ لأنه A will go to 0 مظبوط. A equal to 0, right? When V is equal to constant. So when you are going in the elevator, as soon as you press, second or third or whatever the floor, it will accelerate a little bit. This is when it's most likely if the tension if that tension is going to fail, it will actually fail at start, right? As a result of this acceleration. But then when it's moving at a constant velocity, what happens to the tension? It will be mg. مظبوط خلاص. It's going at a constant velocity. The tension in the cable is not changing. All right. So the motor would actually needs to apply the highest torque at startup. Okay. When it's starting up, right? It has to apply the highest acceleration or the highest torque basically to be able to produce that acceleration. All right, guys. That is what I wanted to say. One last thing. So some of the elevators basically, the acceleration really is, you can define this acceleration, and then some advanced elevators is the acceleration will actually even be variable. So the acceleration will be like this. So when you start, right, the acceleration will slowly increase. These are like, modern elevators. You don't actually feel a jerk when the elevator is, when you're starting the elevator, it moves very slowly. Why? Because the profile of the acceleration as a function of time is like this. So it goes very smoothly and then it's going to go up. As opposed to like, sudden acceleration, like, instant torque. It will basically have a computer to actually create that. Okay, guys, so I think we're good here. Read chapter 13 and I'll see you guys on Friday.
Doctor, when decelerating بتكون tension أقل من mg إنه بس بكون عم يعني بده يوصل ويوقف.
Exactly, then the tension is going to be less than mg. Definitely.
Okay.
While acceleration, it's going to be reversed, right?
Yes.
Okay, it will basically feel less. Why? Because you still have some acceleration going down upward, right?
Yes.
The inertia will actually help you when it's decelerating. Okay, guys, so we are good to go here. Take care. I'll see you on Friday. Make sure you are solving the assignment. Yep.